So guys, welcome back. Okay, thank you. So we're back online and we should be going in about 30 seconds. Just waiting for a couple of other folks to join in. So, okay, seems like everybody's in. Okay, I think we left off at a point where we were talking about the Windows Azure Fabric controller. So the Fabric controller essentially is running on a separate machine, and it manages anything between 4 to 8 machines at a time. What each machine actually they have a Fabric agent, which communicates with the Fabric controller, giving back vital stats of each of the machines back to the Fabric controller in terms of the CPU utilization, the memory available, and hard disk available, all the vital stats of individual machines. And what this helps the Fabric controller in terms of if they were to start a new virtual instance on that machine, they would actually take a quick stab at the performance and then decide whether they want to go ahead and start off with an additional virtual instance or no. At the same time, the Fabric controller would kind of make sure that no two web role of the same application are going to end up on the same physical box. So, and okay, so if you look at each and every each machine, it's going to have a role instance and it's going to have Fabric agent. But apparently, what's not shown in this diagram is every virtual machine which is running on that physical box has a Fabric agent, and there's an advantage to kind of have just there's an advantage to kind of have that kind of functionality at an individual virtual instance level, so that's kind of easier for the Fabric controller to kind of look at if there are a number of users per virtual instance is higher, then it's going to load balance it to another one, and subsequently eventually if you actually had an API code base which kind of gives you additional web roles on the fly, that's going to help you get to that auto scaling which is not in a Windows Azure. So I'm quite sure the Azure team is cognizant of the fact that they would eventually have some kind of auto scaling mechanism, although it's at an API level. At this point in time, I know there are various third-party products who do the same thing. Now, moving further, what you see is the storage. The storage also has a Fabric agent. So, anything and everything which is going to be running on the Windows Azure data center is going to have a Fabric agent for kind of understanding, because that's how we all get the resource to be managed well. So we call it managed resource. So, as you see, the Fabric controller is indeed the most important component in the Windows Azure, and that's where the whole differentiation really comes about. The Windows Azure being an operating system for the data center or the cloud. Moving on further, we talk about content distribution network. So we talked about blobs, we talked about videos and audios kind of stored into the blobs, and eventually what happens is that you have the blobs stored on individual data centers, maybe in the Asia or Europe or North America. Apparently, what happens if there are users who are sitting out in North America and kind of accessing data over the Asian servers, so what the CDN really does, it makes a copy of the blob which you're trying to kind of access somewhere close to New York or close to the US, to close to whichever city you're there. So it's going to have their servers and kind of cache the data. That would invariably make the user experience to be much better. So from a CDN standpoint of view, there are various competition products which are there. Akamai is there, which has been there for a very long time, pretty much. If you look at the telecom industry, a lot of these technologies have already been used there. So coming down to Windows Azure Connect. Now, as stated earlier, now there are applications which are actually running on the Windows Azure compute, which actually want to talk to applications and data which are actually running on on-premise. So when we look at an on-premise Windows computer, there is obviously a case where the on-premise computer is going to be behind a firewall, and it's not going to be accessible to the Windows Azure application which is running on the cloud, or elsewhere the application which is running elsewhere in some other enterprise behind another firewall. How is it really going to get to there? So what happens? The Azure Connect gives you an endpoint agent. And what does endpoint? You install the endpoint agent, assuming you have administrative rights. You install the endpoint agent onto the onto the on-premise computer. What it gives, it basically gets it gets an IP, and the IP it uses IPsec to kind of connect back to the Windows Azure compute. And essentially, what happens is that your machine and the Windows Azure compute end up using the same network, so they end up being on the same subnet mask. So that kind of helps communicating machines. So basically, the endpoint agent essentially is not doing much besides just giving an IP and trying to get the communication across the Windows Azure compute much more easy. And they end up using IPsec as a protocol. So I think this is understandable. Moving on to the next slide, we actually move on to SQL Azure. So SQL Azure is a scaled down version of SQL Server. You must understand that the SQL Azure database has a limitation as of current of 50 gig. So you can't really have a database higher than 50 gig. That actually means that. And you also have facilities, over and above SQL Azure is a SQL Azure reporting, which is something similar to what we have with on-premise SSRS. And however, when you actually do a feature-to-feature comparison between SQL Azure and on-premise SQL Server, there are plenty of differences. One shocking difference which I can see at this point of time is the SQL CLR is not available on SQL Azure. So you really won't get a whole SQL Server experience on SQL Azure. You probably will get about 50-60% close to what SQL Server gives in terms of the management studio and other features of SQL. But the whole lot of features are not going to be really available on the SQL Azure. Moving on further, so most of the communication actually happens via TDS or data. So even if you actually work out a management studio, SQL Server Management Studio, which is hosted on on-premise, and it's actually talking to a database which is on the cloud. So you can actually end up using the SQL Server Management Studio to talk to one of those databases. However, the SQL Server out here if you look at the SQL Server, it's really not a SQL Server per se. It's a virtual instance of SQL Server, and it can actually have multiple databases, and databases can again be stored on separate machines, different machines. So one must understand it's really not SQL, but the inside working of SQL Azure or something. We need to dig deeper, but as we kind of decipher what's in there, we get a better idea in terms of what the internal architecture really going to look at. Moving further from a SQL Azure data sync standpoint, there's obviously a need for databases in SQL Azure to kind of synchronize data with maybe other SQL Azure databases, or maybe an on-premise SQL Server. But mind you, this sync is really not something what we heard of a sync framework. It's different. So it's only a configuration related thing, and it's not even SSIS. So SSIS would probably do much more than replicating data, to SQL Server, which can actually go across different databases. Having said that, so SQL Azure Data Sync is, however, only a configuration related thing. Okay, so getting on to Windows Azure App Fabric. Plenty of big stuff actually happening out here. The new release is going to have a lot more stuff. I'm sure when you actually kind of open up the Azure Management Portal, you're going to find tons and tons of new stuff actually coming on the Azure App Fabric. But we're going to restrict the conversation to three green areas marked out here: the service bus, the access control, and the caching. So if you look at the service bus, the service bus is I really don't want to get into an argument about whether we need or not a service bus. I'm pretty much sold on the argument of service bus. But if I want to give you a problem and try to kind of give you the whole rationale in terms of behind of using a service bus, you have an on-premise application which is talking to another double shift service which is running on-premise somewhere else. And so how these two applications are really going to talk, both of them are behind the firewall. And if you really look at it, it's if you look at most computer problems, so software problems, it's all of them, have, most of them get solved by one basic rule, the rule of abstraction that we call. So you go ahead and introduce in another layer of abstraction, and we call it the service bus. So what the service bus really does is it's going to act on your behalf, and just the very fact that most of the applications which are running don't have fixed IP. So what's it really going to do? The WCF service, which is actually running on premise, it's going to go ahead and register the endpoint onto the service bus. Service bus actually has a registry. So, and when it does, it opens the TCP/IP connection to the service bus and keeps it open, keeps it that way. It doesn't really close that thing. And the service bus in turn is going to go, once the registry has been done, it's going to expose the service bus endpoint URI, and it's probably you can actually broadcast it using the DI, and be available for discovery. And you have your client on premise, which tries to discover the service. It probably gets the endpoint, and it gets the whole WSDL of your service, and it invokes the operation onto the service bus. So what the service bus does, it translates that call into the endpoint call, and invokes the operation on the service on the endpoint. And how does step number 5 really happen? You need to understand that the WCF service, which is actually talking when it registers service endpoint, it opens a TCP outbound connection and keeps it open. So when the file comes back in, it probably thinks this is TCP in, and it goes ahead and allows that. So that's how it actually works. That's the whole science behind the entire stuff. So service bus is a very important component. We're going to have a dedicated session only on service bus, and there's a lot more to it. So I'm just going to move on further to the app fabric. The app fabric access control. So now when you kind of deploy applications on the cloud, there is obviously a reason to have some kind of authentication or authorization. Now, well, you can actually go and have a user ID password kind of basic authentication, or you basically want to have an application have a single sign-on with your Active Directory on premises, or you may want people to sign into your application using Windows Live. So whatever applications you're building, you obviously want to support various identities. So when I say various identities, it can be Active Directory, it can be Windows Live ID, it can be Google, it can be Yahoo, it can be Facebook. So, and there are many others which in that space. So obviously, if you're a developer, you write an application to the cloud, you really don't want to sit and deal with IDP tokens of so many different identity providers. So as always, we have a solution, we have a problem out here where we have multiple identity providers, we have an application, and we know the applications are actually going to be having wanting to support a lot more identity provider. A lot more application would want to kind of go ahead and use that. So what do we do on that? We go ahead, introduce another layer of abstraction. We call it the access control. So what the access control really does, so if I go down to the flow, we have one which goes access application and get it's access the application on premise or on cloud. So what the application does, say, hey, you're coming down to me, you need to go back to the IDP and talk to them. I'm not talking to you unless I really know who you are. So what does the browser do? It basically goes ahead and talks. It basically flashes, okay, say, all right, how do you want to get into the how do you want to log into the site? Do you want to end up using your ADFS, your Windows Live ID, Google, Yahoo, what? So basically it's going to throw a screen with multiple options of identity providers. So you as an end user would basically click any either of them. You'd enter your user ID password and send it out. And so what happens? You get an IDP token back in return from them. This IDP token is then sent over to the access control. The access control goes ahead, validates the IDP token, and then creates the access control token. This is one. So basically, it's so many identity provider tokens, IDP tokens. All of them get translated into a single access control token. and it basically checks your access management rights, whether you're allowed to use this right. So there's a rule engine which actually kicks in out there and returns access control back to the browser. The browser then picks up that access control token and sends it to the application. The application validates the token, say, "Oh, you're coming in." It checks the claims. It checks whether all right, you got the right authorization, and goes ahead and gives it to you. So access control, I'm sorry, is an important piece. We're gonna have a separate session. I'm sorry, I'm trying to choose something while I'm talking. I'm kind of hungry. So access control is an important feature in the whole Fabric thing, and there's a separate dedicated session. So when you actually get down there, writing your code, you probably understand things better. Now this is one area which I'm not too convinced, but I'm going to try to talk about this. So caching, you've been using caching in your applications for quite some time, and you have caching enabled at an ASP.NET Cache level, and you can actually have a central state server as well. In the cloud, when you actually deploy an application, the application's going to have an application cache, but the application cache really doesn't make sense, because in the cloud and in the web role, if you land up to a specific web role as an end user, you're really not going to come back there. So if you're really not really going to come back out there, what happens? So you obviously need a centralized caching service, which is going to store your data, and as when you get back to the application has to go back to the caching service and say, "Hey, this guy's come back again in. Can you just give me so and so?" I mean, so you end up using some kind of view state, something around that. So we would actually get deeper in terms of how to manage states within applications running on the cloud a little differently. So when we get into the application developer session on the cloud, that's where we're going to get deeper into the caching. I'm going to leave it out here. The Windows Azure Marketplace. Beautiful concept. It's pretty much available on Android. I think it got picked up from Apple. So the marketplace is essentially data market, sets of data and applications. What does the application really have? It's got finished application, it's got application components, it's got training and consulting, so it's another revenue making stream for Windows Azure. So obviously whatever you build, you really want to go ahead and sell it. You want people to use it. You want to make money out of it, and that's exactly what you're going to get. Azure Market Data Space, again, it's data sets. It can be stored in tables, SQL, Azure, and you have data access, so it's pretty much the same stuff using the rest of the OData. Yeah, the last but not the least important slide. Take this with a pinch of salt. This is very important. Windows Azure platform pricing. Now, for every compute on each role instance is going to be about 0.5 cents to 0.96 cents an hour, depending upon the instance size. When I say instance size, you can have anything between extra small to extra large. Now each of them has various classification in terms of number of cores, memories, and so on. So that's how you kind of define the instance size. Storage. Windows Azure blobs and tables, they're the cheaper option. So the data which ends up using the blobs of the tables, it's roughly about 0.50. It's about 15 cents per GB per month. And don't you forget, whatever you've written into the tables and blobs, you can definitely access this. And access out here is about 0.1 cents per 10,000 operations. SQL Azure, relatively expensive. It's about $9.99 per GB per month. Now, I don't know if there are really any classifications on the SQL, but from an instance size standpoint of view, but I think that's something which Microsoft needs to clarify. So you got a handle on the compute, you got a handle on the storage, and you need to get a handle on the bandwidth as well. So basically, what goes in and what goes out also is charged. So in North America and Europe, it's about 10 cents per GB in and about 15 cents per GB out. In the Asia Pacific, it's about 10 cents per GB in and 20 cents per GB out. Now, you probably argue that, we from Asia, and why is this damn thing more expensive on an out in Asia? So there definitely has to be some market economics to be kind of calculating that figure. But lastly, this is Azure platform pricing. When you sign up for your Azure accounts, please bear that you're going to be charged. So the first 3 months accounts usually you get is extra small size and 750 hours free of cost, but eventually it's going to charge on a credit card. That's it from me. And if there are any questions, I'm more than happy to answer them right now. If not, I'm just going to go ahead and call it a day, and then it's weekend and go and make the best of the weekend. I'll wait for questions. Okay. Okay. All right. The question is classification of the pricing. Is there a classification on the components pricing as well from a service bus and a queue standpoint of view? Yes, I believe. But apparently, I don't have the data. So in the next session, as we drill down into the Azure Management Portal, I would try to give you the pricing on the individual components as well. Yes, that's a very, very valid question. Okay, so the Windows Azure is a 1 million core data center. Obviously, it's been spread across various geographies: North America, Europe, and Asia. And when you sign up for any specific service on Windows Azure, maybe when you're trying to host your tables or data or SQL Azure or your application, it's going to ask you where do you really want to place the application. Do you want to place it into Africa, into the regions of Asia? Within Asia, also there's a classification: Far East, Southeast Asia, South Asia. So there are various classifications. So I'm guessing that there are multiple data centers within Asia. Yes, they are multiple data centers, but there could be more than 3 or more than 4. But the actual number is something which I don't have at this point in time. Okay, I guess there are no more questions. Thank you for attending the session, and I look forward for your feedback and more questions. And I would be having my next session coming up very shortly. So I would be having my next session coming up very shortly in about next 2-3 days time. And please watch the space. You're going to get a lot more data. And whatever's written, now I'm going to be talking a lot more on this. Thank you, ladies and gentlemen.